You render a cinematic shot of a skateboarder landing a trick. For exactly 2 seconds, the footage looks perfect. Then the face morphs into unrecognizable geometry. The limbs snap backward into spaghetti, and the camera aggressively drifts off its axis. It is easy to blame the rendering engine for these visual failures. The reality is that this chaos is the direct result of sloppy, unstructured prompting. Engines like Seedance 2.0 and GPT Image 2 are highly capable ecosystems. They do not operate on vibes or loose creative suggestions. They require a strict mechanical framework to function correctly. Achieving hyper-consistent video generation requires replacing guesswork with rigid, non-negotiable rules. Treating the AI as an inflexible code compiler, rather than an intuitive creative partner, moves your output from amateur trial and error to studio-grade control. To move past the chaos of trial and error, you must adopt a standardized prompting syntax that the engine can parse reliably. This diagram illustrates the core 6-part prompt formula. It reads linearly: subject, action, environment, camera movement, style, and finally, constraints. This final piece operates as a strict firewall. Explicitly commanding the engine to avoid jitter and bent limbs protects your prompt from physics errors. Once the text is locked, you bring in external reference files. Simply uploading an image or a video tag without explicitly assigning it a role is the most common mistake creators make. Every image tag needs a precise job. You must explicitly state whether an image serves as the exact starting frame, the final closing shot, or a locked reference to maintain a character's design. Video tags operate differently. You use them to extract specific technical data, instructing the AI to either copy the original camera movement or replicate the exact choreography. Dictating the exact purpose of every single uploaded asset removes ambiguity. It stops the engine from improvising and keeps your shot on track. Generating reliable motion requires directing the AI camera with strict physical boundaries and precise trigger words. This 3x3 grid maps the 8 native camera paths: push-in, pull-out, pan, tracking, orbit, aerial, handheld, and fixed. To prevent AI confusion, you must separate instructions. The grid dissolves into a parser. Write one isolated sentence for character action and another for camera motion. Asking the camera to move too quickly destroys those physics. The word fast is the primary cause of severe visual jitter and warped limbs. Camera control handles motion, but keeping a subject visually identical across a sequence requires different methodology. To maintain a character's identity, you cannot change a single adjective. You must copy and paste the exact physical description into every single prompt without altering the wording. Pairing that verbatim text prompt with a locked anchor reference image leaves no room for interpretation. You force the engine to memorize a specific identity rather than hallucinate a new one in every clip. Following these rigid rules provides a massive operational advantage by saving production time and budget. This chart shows the actual economics of generation. At roughly 5 cents per second of API usage, producing a fully realized 3-minute AI short film totals out to $15. That budget can evaporate quickly if you fall into the editing cost trap. When a generated clip fails to match your storyboard, attempting to use the engine's targeted local edit feature is a mistake. Local edits charge approximately double the credits of a base generation. It is mathematically and practically superior to tweak your text prompt and request a completely fresh regeneration instead. Lock your 6-part formula. Assign explicit roles to reference tags. Separate camera directions from subject actions, and never paraphrase your character descriptions. Mastering these mechanical constraints ensures the engine delivers exactly what you scripted, without the interference of random drift.